Hello everyone. We are Group 23 and we will be proposing the aquarium management and monitoring system. Before we start, let's have a simple introduction of ourselves.
My name is Benji. I am a Year 4 CPEC student.
My name is Jaspreet and I am a Year 3 Computer Engineering major student. For our project, we wish to create a small-scale embedded system which can simulate a working aquarium. It will have all the basic necessary functions required in an aquarium, such as monitoring environments and protecting species from theft.
We are dividing the functions of our system under three modes. In the environment mode, we will be ensuring that the water is within the optimal quality levels. We will be using sensors to check pH, temperature, and the water level. If one of these parameters go out of range, we will be notifying the user with LEDs. For the security mode, we will be protecting the fish and other species within the aquarium. If a stranger gets too close to the fish tank, then the buzzer will go off, alerting the owner. For the feeding mode, the owner will be able to feed the fish without physically being present over there.
The role of the microcontroller can be divided into three main segments. The first segment is the microcontroller being a management system for all the sensors. The microcontroller will be responsible for handling and displaying input and output operations from the users and the sensors. In this way, it can manage all the sensors simultaneously. Secondly, the microcontroller will also be used for timing configuration and clock. The internal timer will be used to calculate the exact time to feed the fish. When the time is suitable to feed the fish, the motor will be used for mechanical action of feeding the food to the fish. The timer will be used for producing a PWM signal for the motor to turn. Lastly, the microcontroller is also used for input-output notifications of unsuitable working conditions.
For our sensors, we will be using an LDR. It will enable us to determine when a stranger gets too near to the mouth of the aquarium. Since the stranger will cover the light above the mouth of the aquarium, the sensor will be alerting us. Another sensor that we will be using is the temperature sensor, which will monitor the water temperature. We will be also using a pH sensor, which will monitor the pH temperature, and a capacitor proximity sensor to monitor the water levels. The models of some of the sensors we are using are not finalized. We are open to suggestions.
The RGB LED is used for notifications. By default, the LED is turned off. If the pH level is outside the suitable range, the LED will switch to color red. If the temperature is outside the suitable range, the LED will switch to a color green. And if the water levels have gone under the specified limit, the LED will switch to blue.
For our additional devices, we will be using a servo motor that will be activated to open the feeding tube. We will also use an LCD screen for getting the user input and displaying the sensor outputs. And we will be using external buttons. We will need 4 buttons in total.
The LCD display acts as a visual interface for users. The users can define their own suitable pH values and temperature values. They can also input the feeding time. Now 2 switches will be used to increase and decrease numerical input values, and 1 switch will be used to navigate in between the user input spaces. With every click of the switch, the cursor will move to the next input, so it loops over all the available 5 input locations.
This is the end of our presentation.
Thank you very much.